Welcome to aminacademy.com. Let us do Tamil Nadu SSLC Maths Textbook Exercise 3.3, question number 1. Find the LCM and GCD for the following and verify that f of x into g of x equal LCM into GCD. Now, first question, let f of x equal 21 x square y and g of x equal 35 x y square. Now further, f of x we can split 21 as prime factor is 3 into 7 x square y. Here g of x is 35 is 5 into 7 x y square. Now GCD, greatest common divisor. Here 3, here the 7 and 7 is a common prime factor, that is 7 into x square, and x common is x, and y square and y common is y. Therefore GCD is 7xy. Now LCM is here for 3 into 7, 3 into 7. Here 5 into 7 is there, we have to write 5 because already 7 written, and x square and x, highest power is x square, and y square is y square, so which is equal 3 into 7 is 35 into 5 is 105 x square, y square is the LCM. Now let us check LCM into GCD equal, we have LCM is 105 x square y square into, and GCD is 7xy. So 7 5s are 35 and 7 ones are 735 x square into x is x cube, y square into y is y cube. Now let us check f of x into g of x. Here f of x is 21 x square y, and g of x is 35 x y square, which is equal 21 into 35 is 735, and here x square into x is x cube, y into y square is y cube. So therefore both are having same answer. Therefore we verified LCM into GCD of two polynomials is equal to the product of that polynomial f of x into g of x. Then let us do the second question. Suppose f of x, let f of x is x square minus 1 x plus 1, and next g of x is x cube plus 1. 1. Here x square minus 1 we can take as it is. Here x cube plus 1. X cube plus 1 is the factor is x minus 1 x square plus x plus 1 and x plus 1 is already there. Here x cube plus 1 is factor is x plus 1 into x square minus x plus 1. Now we have f of x have the factors and g of x also have a different factors. First we'll find GCD. Here GCD, the common factor is here x plus 1, no other common factor. So GCD of this f of x and g of x is x plus 1. Now LCM is first write these things, that is x minus 1 x plus 1 and here also x plus 1. One time we can write, then write here x square plus x plus 1 x square minus x plus 1. This is our GCD. Now we'll do check LCM into GCD of these two function is here LCM we have x plus 1 x plus 1. First LCM is x minus 1 x plus 1 and x square plus x plus 1 x square minus x plus 1, that is LCM into GCD is x plus 1. So let us split here, that is first x minus 1 into x square plus x plus 1 gives x cube minus 1 and x plus 1, this x squared minus x plus 1 is x cube plus 1, then that extra thing is x plus 1. So this is a product of LCM and GCD. Now we'll find f of x into g of x. F of x we have x cube minus 1 into x plus 1 and g of x x minus 1. First f of x will write as a splitting factor. F of x is x minus 1 into x squared plus x plus 1 x squared plus x plus 1 into x plus 1. Then g of x is x plus 1 x plus 1 x square minus x plus 1 x squared minus x plus 1, which is here we can get x minus 1 into x squared plus x plus 1 is x cube minus 1 and this two things becomes x plus 1, x square minus x plus 1 is x cube plus 1, and this one more extra factors are x plus 1. Here let it be 1, this is 2, from 1 and 2 we can say LCM into GCD equal f of x into g of x. Hence we proved. Then third question, x square y plus xy square and x square plus xy. Let f of x equal x square y plus xy square, which is further by factorizing xy common, x plus y. Then g of x is given as x square plus xy, which is common is x plus y. Now we'll find LCM. LCM is xy and x is common is x, y, and x plus y. And GCD equal common of both is x is common as well as x plus y. Now LCM into GCD equal, let us give a little more space for this. LCM into GCD, here LCM is xy, x plus y, into GCD is x xy, x plus y. So it gives x square y into x plus y the square. Now f of x into g of x. Here f of x we have f of x is xy, x plus y, into g of x is x into x plus y, which is equal xy into x is x square y into x plus y into x plus y is, let's say, whole square. Put 1 and this 2. From 1 and 2, 1 and 2, we can say LCM into GCD is equal f of x into g of x. We have done. Please subscribe our YouTube channel.